So today I want to talk about heat detectors. What I have here is a conventional non-restorable heat detector. So when I say conventional, I mean it's just going to act like a switch. It's just going to be able to send an entire initiating device circuit or zone into alarm. So depending on how many of these I have on a zone, they're all going to send the same signal. I could have an addressable heat detector, which means that it's going to be able to send its address as well as whether or not it's in alarm. So that would allow me to be able to pinpoint exactly which device is in alarm. And then if it was analog addressable, it'd be able to tell me its location, its address actually is, and then tell me the specific temperature, and then the control unit would be able to set those alarm set points. But this is an example of conventional, so it's basically just a switch, and it's non-restorable, which means once it activates, it's done. So the way that this works is I've got a plunger right here. This plunger is held up by some solder up inside of the detector. And then on the back, I've got these two connections, these two contacts. So I'm going to attach my initiating device circuit on these two contacts. And then basically, once this heats up to its specific temperature, this plunger is going to fall away, and it's going to allow these two contacts to close, and it's going to create that alarm condition on my initiating device circuit. Could have a restorable type conventional, which essentially means that once it goes back to its normal temperature, it would then open up those contacts again. But this is the case of a restorable.